always get Falcon Space t-shirts and hoodies. If you come down to the lab, that is. We do have an update now. We did have a bit of a problem with the camera before, but that problem has been fixed. And Tim, if you highlight the slow-mo, pin that computer right now, you can see we did get some images from the high-speed camera. Here's sign 1. This is it firing. This is the image after it fires. You can see sort of like a black void where the where that arc over happened. So also, interestingly, the arc over is happening mostly from the periphery around the superconductor. So that's where there is some, that's where the copper pipe is. So we might want to try shielding that for future experiment, just to shield the copper so that the superconductor is what's emitting the beam rather than it coming off of the copper. That's one thing that we noticed in this image. In this image, we're looking at a different frame rate, so we're getting more light coming through. Again, you're able to see the black spot where the beam used to be. I don't know if that's an aberration of the camera or if that's something that's physically there. The laser beam doesn't show any changes. I don't see any visible wiggle to the to any of these hanging lead weights. So for now, I would say Podkletnov is busted. The Podkletnov gravity impulse, it has not worked as of yet. We should try covering the copper pipe that's holding the superconductor, so we get the conduction directly in from the superconductor. And these kind of experiments are stuff that are ongoing in the lab. These are works in progress. So you know, so long as there's liquid nitrogen and there's interest, we're going to continue trying to get to the bottom of this and going. I definitely want to go to NTS for a high power run at this, and we have an RV with mobile internet hookup that will bring up to their facility in order to see it there. So this is sign 3, sign 4. The sign is these are the cuts out of the memory chip, high-speed memory chip that it gave us. Again, we see the high voltage is coming. It's arcing over from the copper to the silver. It's not coming directly off of the superconductor. So that may be a problem. Sign 5, we see it's slightly more powerful. When we give the Mark Spank more time to charge up, more joules get stored in it. It also depends on atmospheric conditions. It fires earlier at a lower voltage. We're talking about less power. That's why we're seeing differences in the spark between each firing. This one looks like a slightly weaker spark over here. And it's probably at a higher frame rate of images. You can see a little bit of an afterglow there. But here, moving 12, 13, 14, 15, 16 images past the firing, and we are not seeing any visible movement. I mean, you guys are watching literally the same screen that I am. So if you see anything that I'm not commenting on, please make sure to talk about it, because you're literally seeing the same thing. Again, here's sign 1. This is the image right after it. You can see a little bit of the afterglow over there. The top glow is like an orange. That's probably more atmospheric, but then it goes into this bath of liquid nitrogen, and we're seeing a little bit more greenish color to it. That's when liquid nitrogen is getting energized. And the color inside of the chamber, this is that's the glow of helium getting charged up. And here we can go on to this one is probably at a different frame rate. So we're seeing everything much brighter. You can see what the actual setup looks like. But then again, we did not see any visible movement here. So far we're not seeing the kind of results that we would like. I do not want to call this busted as of yet until we try it at NTS with their megavolt Marks bank that can pump out megajoules of power. So yeah, that's it for now. That's what we're able to catch. And the device is still working. It did not spring a link this time, so it's solid. It's ready to go to the next stage of experimenting, and we will take it there.
I think. Oh yeah, I think if you
go ahead.
I think if you had more current going across the gap.
I agree.
And then also if you move the lead weights closer, get them as close as you can to the chamber.
He said it worked up to 10 kilometers. If I move them any closer, you'd be covering the laser image.
Okay. Yeah, because I'm just thinking that
I definitely agree with the current. There isn't
movement,
much current in this thing.
Sorry?
Alex Robertson, Startron, he mentioned that it was rotating superconductors. That's a different experiment, like Robert Chambers said. But if you manage to get this set up and get a rotating superconductor, oh my God, I'll definitely buy you a drink. If you can make this superconductor spin.
He might be right, because the rotating superconductor makes a London moment, which is like a magnetic field, makes its own magnetic field. So that could help. You know,
oh, it definitely will help if you can get it to do it. That's another thing.
It's not exactly easy though.
No, it's not easy.
That thing is glued right in there. It's not moving anywhere.
Well, no, this setup is for sure not going to do it, but if you could devise a setup that can do that, apply liquid nitrogen, high voltage, rotating, Helmholtz coil, and conditioning coil, damn, you're good. So yep, that's it, guys. That's it, guys, with this experiment. We're gonna continue running some more experiments, and just because APEC is ending here doesn't mean it's the end of the experiments. Definitely be sending out some links and doing live streams here and there.
The experiments can never end.
Yeah,
and there will be more even once this shuts down. With Mr. Reif and Gerald, myself, and many more.
So on that note, guys, Mark, let me put this thing on here. Let me unpin this. And let me put this on gallery view. And everyone, please give, again, a tremendous applause to Mark Sokol. Mark, that has been a wonderful long-term project. You know, and the thing is, even if you get a negative result, it's still an experimental success, right? That's the way I look at it. You got all of the issues fixed with it. So it's like Thomas Edison with the light bulb, but at least you made the light bulb, and the light bulb is well built, right? So even if you get a negative result, which may not continue, every time you test this, you're able to do little things, and then sometime you'll hit it. So
right, it's tweaking it each time going forward, and each one that you do, you record it so it's documented, then you tweak something, try it again, and hopefully get a new result out of it. And Mark is very excellent as well with Falcon Space at sending out notices well in advance, days in advance of when he's doing his live experiment streams, unlike myself, where I'm usually kind of spontaneous, but getting on the Friday night science streams on a regular thing.
Spontaneous, you mean by sending me a notice at 2:30 a.m. that you're going live in 10 minutes?
Right, yeah, so it's because I work with a lot of Australians and Europeans too. But yes, Mark is very good with days in advance notice, and I'm going to be working on doing that as well as not just the spontaneous midnight science streams.